did you think you're supposed to do here?
Well, it was X. Well, could you use not the distributive part, what we were doing last week where you add 4 to each side? Could
Yeah,
you do that?
that's exactly what you would do. You treat it like last week. So when you add 4 to both sides, okay, so the first thing is you come up with that answer, and how do you describe it?
X is greater than or equal to 20.
Okay, now graph it. Go ahead and put the complete number line in, even to the left. And then you show your answer by shading. So, Matthew, why did you put a closed circle there?
Because it's in.
Because it's an equal, it's underlined. Okay, good. So what about the next one? Nadia, you want to do the next one?
So I will add 14.
You'd add what?
I would take away 14.
But you want to isolate x, right?
Oh, I would add 10.
Yeah, you'd add 10. Before you jump to the answer in your head, show the step you just erased. What were you getting there?
I'm going to do 24.
Right.
It's less than or equal to x.
Right. And so how do you say that starting with x?
X is greater than or equal to 24.
Right. So think of it left, where you're always reading from x. So how are you going to draw a graph of that? So close circle on 24. And where are you going to shade? Good. Okay. And so if we look at this one, there's a couple things here that, let's make that a less than. Oops. Okay. This right here is different. So how would you shade the picture of this? Draw it on your paper right now. Just draw a picture of what you think the solution to this is. And you can't say something about negative x. You have to say something about positive x. So on a piece of scratch paper, come up with a picture that would make this, that would tell us about x here. Okay. If you're not sure how to do this picture, think about this picture. We're talking about all the numbers that make it true that x is bigger than 20. So, for example, an easy number over here is 24. And the reason I'm saying that's easy, if you go back to the old way of checking, what's 24 take away 4? 20, right? And is 20 bigger than 16? Or equal to? Yeah. So we know the shading's on this side. Your answer should make logical sense that way. Okay? So when I test numbers, if I was going to test Nadia's answer, I would say, well, I'm going to 30's over here, right? So is 30 take away 10? Does that make sense? What's 30 take away 10? 20, right? And is it true that 14 is less than or equal to 20? Yeah. So if he had shaded the other side by accident, if he had shaded this side, then I would have picked like 20. I would have checked it with 20 and found out that it didn't make sense. If I put something like 20 in, 20 take away 10, what's 20 take away 10? 10, right? So this is 10. And is it true that 14 is less than or equal to 10? No. That's why we didn't shade on this side, because it's not true. So how do you shade a picture that represents this? Down here, where you show the shading and the shading makes this true. And that's what you're supposed to be drawing. All right, I can tell this is confusing, which is why I wanted you to think about it before we talked about it. Sometimes if we just do something, it seems obvious, and then you get home and you're not sure why it worked. So it is confusing. Okay, it is confusing a little bit. So here's what I want you to do. I want you to think about, let's just think about guess and check. Okay, what kind of numbers? So Nadeem, I'm going to have you hold your thought because you have that written down right. But I'm not sure how many other people did. If I was just going to guess and check, okay, and think of numbers that would make this true. Just, can anybody think of a number that makes it true? Yeah, Xander. Negative 12. If I put in negative 12, that's negative 12, which is the opposite of negative 12. Is 12 less than 31?
Yes.
Okay, so negative 12 works. So we would say negative 12. Are there other negative numbers? What's another one?
Negative 6.
Okay, negative 6. How close to 0 can we do that? Opposite of negative 6. Is that less than 31? Yeah, 6 is less than 31. So, okay, so positive 6 works, right? So we can even cross over. 0 works, right? 6 works. Positive 12 works, right? Because 30. Okay, let's start talking about things in the 30s. If I put a 30 here, is negative 30 less than 31? Yeah, so all the way over here, 30 is going to work.
Couldn't you do things higher than 30 if it's positive?
Let's try. How about 40? If I put, I mean, this is just to develop intuition. It's not how you're going to do every problem. If I put 40 and it's negative 40, is that less than 31?
Yes.
Yeah. What if I put a billion in? Is that going to work?
Yes.
Yeah, so doesn't that mean at least I know my shading's got to go this way? Where does it start?
I told you.
Well, it couldn't start at 0 because negative 12 worked. Well, what about negative 20? Okay. No, because if I put in negative, let's go negative 50. That's the opposite of negative 50. What's the opposite of negative 50?
50.
Is 50 less than 31?
Yeah. Oh no.
It would actually be
31.
31.
31. You can't include it though. Think about it though. If we put negative 31 here and make that open because it's not underlined, right? It's got to go that way. So let's see how we can make this more sensible. Noah.
Could you take a chunk of numbers and not have it go on forever? Like you could have
You,
30 and then you can have it go to 31.
no, because even negative 30.999999999, which would be in here, right? So don't forget about those. So that's like intuitive, but that's not going to help you get comfortable with it. I just want you to see that it's not as obvious as it looked. I walked around the room and I saw one person with the right answer. And then there might have been more because I didn't make it over here, but that's usually a good sampling that it's not obvious. So let's talk about how to make this more logical, because this is the only real challenging part today. Think about this as, can I do things like this? Can I add x to both sides? Can I do that? Well, but we did it. We've been adding things to both sides all for a month now, right? As long as they're the same. You can add the same thing to both sides. What happens with the left-hand side?
You get 0.
You get a 0, okay? And then on the right-hand side, you have 31 plus x, right? No, it's just 31 plus x. But this is a positive 31, right? I want to isolate x. I want to get that alone. So, Ingrid, what do I have to do?
Subtract 31.
Subtract 31 from each side. And so now I have negative 31 on the left and x on the right. And when I read that, I can read that from right to left or rearrange it so x, and you see the white part is going towards the x. X is bigger than negative 31. So you put the negative 31 like we had, it's an open circle, and you shade to the right. So raise your hand if that makes sense. So guess and check is great to develop intuition, but it's not great to do a problem like this because you want to have it quicker. Okay? Xander.
I got the right answer, but all I did was flip it around. I'm pretty sure that's the I just did an x, because if negative x is less than 31, I just did it. And my own point gets right. So.
Well, it's actually true. There's a shortcut. So your intuition's right. If x is bigger than negative 31, I mean up here, if negative x is less than 31,
I just did x.
positive x has to be greater than,
You just switched the,
That's all I did, yeah.
you just switched the negative sign.
well, you have to switch to the inequality. Look what happened, you guys. We started here, right? We had a negative x and a less than.
Just switch the two numbers.
And a positive, well, be careful. Be careful. But now we have a positive x and a greater than and a negative 31. You just don't, you have to understand what you're doing if you're going to use a shortcut. Okay, so let's talk about that. If I have negative x is bigger than or equal to negative 16, and we go the long way for a minute, I would add x to both sides. Does that make sense? The long way is the best way to understand the shortcut, and then you can use the shortcut. So this gives me what on the left-hand side? 0, right? And what do I have right on the right-hand side, Emma?
Negative 16 plus
Negative 16 plus
x.
x. Okay, now I want to isolate x, so what should you do? Keep going.
Add 16 plus x.
Add 16 to both sides. Okay, so keep going. What do you have on the left?
16.
And the sign stays the same, right?
And then
And then you have x. So Vanessa, if I rearrange it and put x here, what do I do with the sign? It's less than or equal to 16, right? So look at what we started with, and look at what we ended with. So if we go to 2 pages here,
I still think the long way is easier.
the long way may be easier for people, some people all the time. So, and that's fine. So if we look at what we started with on both sides, if you have a negative x here, and you end up with a positive x here, what happened to the sign?
Positive.
Well, the sign's not this sign, the symbol, the inequality.
Flips.
It flipped. And what happened to the number on the other side?
Turn to a positive.
It switched to the opposite.
Oh, they both. Everything switches.
It doesn't switch to a positive unless it was originally a negative.
Everything switches.
Everything switches.
Oh, okay. So that's everything.
Well, be careful because you just said the long way's easier, so make sure you don't rush. That's the only thing.
Get that. I thought it was just like you flip the negative at first.
Okay, so don't rush, and it'll work out. Natalie?
So I'm confused on why you put the sign.
I didn't. Okay, because from here, you mean?
Yeah.
I could have just said x is bigger than or equal to negative 31 when I look at this, but in the standard is that you always start with x. So since you have x over here, you know, you need to think of it as how do you write your final answer? Put x first. So that means when you look at the symbol, the symbol was the wider part was facing x. So you have to still make the wider part facing x.
It only works if there's negatives, right?
Right, nothing's, we just, exactly, right? When we looked at the first one, nothing was fancy, right? It was just like the regular stuff. There was no negative x up here, so you just treat it like an equal sign. Olivia?
Were you doing that 16 minus x is greater than or equal to 7? Is that what you were doing?
No, I wasn't.
Okay.
Let's do that now.
That
Okay, so let's try that one. Right here, so I want to isolate my variable x. So remember, keep in mind 16 is positive. So what should I do with that to both sides? Decent. But it's already positive.
Oh, I thought it was negative. Oh, then. Wait. What?
So if it's positive, treat it. So what's the opposite of positive? So think of a subtraction operation.
Oh, okay, so
Subtract 16. Sometimes it's confusing when the constants before the variable.
So there we kind of have to do all that now.
No, you don't have to, but let's see what Easton's going to do. So what would you do next, Easton?
Then you would have. Then you would have.
So you have a positive 16 and a negative 16.
And those would cancel.
Those cancel, and you just have negative x now. Even though it was subtract x, you're going to think of it as negative x. And then you have greater than or equal to what? Negative 9. Okay, so now you have to make it a positive x, because we always want to start every answer as x is something. So how are you going to get that positive x? Your choice.
So wait, was one of the ways you could add x?
Yeah, go with the way that makes the most sense to you. Add x to both sides. That'll work. So now you have 0 less than or bigger than or equal to x, take away 9. Now what?
Then you would add x plus.
Perfect. Add 9 to both sides. And so 9, and then you have the x, but you really want to write your final answer as x first, so now what?
Is x is less than.
Exactly. X is less than or equal to 9. So then you have a closed or an open circle over 9.
I mean close.
Okay, close. And does it shade to the right or to the left?
To the left.
Perfect. So really what she's doing is probably the best way for everybody at first, is to think it through the long way, because then the shortcut's going to make sense. Shortcuts don't stick with you forever if you don't understand where they come from. If you just memorize them and you wait a month and you don't practice any problems, you're probably going to make a mistake. If you know the long way, you'll develop intuition for the shortcut.
Wouldn't that be
Is it-
x minus 9? Wouldn't that be 9 minus plus x? Negative 9 plus x.
Say that again?
Like we're in this, I think third step.
Negative 9 plus x.
Shouldn't it be negative 9 plus x to x?
Right here?
Yeah.
Okay, so let's check the work. Maybe there was a mistake that I didn't see, but these cancel.
Right?
And so you have x take away 9.
Yeah.
Or you could write negative 9 plus x.
Oh, that's okay.
It's fine, but x take away 9 is a little easier for a lot of people, because then you have the variable first, and this is a takeaway, so you add 9. So now you add 9 to both sides, which makes these cancel, so you're left with just an x and a 9. But it's true, you could have written it as negative 9 plus x. I think that's harder for people. So it might not be for you, though. So you could do that way. Cal.
So when you solve an inequality, do you bracket all of it?
So today, right, if we were going to look at your homework, there's not a lot of problems there at all today. So don't rush through and do it, sloppy job of it. Take the time to copy each problem, show the work, draw a good solution, and make sure you really understand it, because as we did last time, whenever we started something simple, the next couple days it really picks up. It gets harder.